This is a continuation of section 2.1, 2.2, and 2.5 writing equations of polynomial functions. For examples 5 and 6, you'll see that our instructions have returned to find any polynomial function that has the given zeros. So remember, we do not have to be specific for the leading coefficient here. So if I have zeros of 3, a 0 of 4i, and a 0 of negative 4i, then I can use each of these backwards to write my factored form of the polynomial. So the polynomial is equal to x minus 3 times x minus 4i times x plus 4i. If we stop here, we have the linear factorization of the polynomial. Linear factorization meaning that each function or each factor is in linear form. X minus 3 is linear, x minus 4i is linear, and x plus 4i is linear. To go ahead and find the actual polynomial function, we need to do the multiplication involved so that we have unfactored form. I definitely think it's easier to multiply the complex roots first, or the factors with imaginary values, because we know that these are conjugates of each other, and we have learned that with conjugates, multiplying the first and the last term will save you some time rather than multiplying all parts of FOIL. So x squared, and a negative times a positive would give me negative 16i squared, and as you can recall from class, negative 16i squared converts to positive 16. And now we can multiply these final two binomials, x cubed minus 3x squared plus 16x minus 48. We don't have to worry about the leading coefficient because we were given no instructions, nor were we given a solution point. So what I'd like for you to do for number 6 is to write each of these zeros in factored form and then check to see if your factored form matches mine. So pause the screencast, please, and try to first write the polynomial for number 6 in factored form. Okay, so I have 1, 2, 3, 4 zeros. I know we only see 3 zeros, but recall that zeros that are complex come in conjugate pairs. So in addition to 2 plus 5i, we should have a 0 of 2 minus 5i. So let's check to see what your linear factors look like. The minus ones give us factors of x plus 1 times x plus 1. And then the factor of 2 plus 5i gives us x minus 2 plus 5i. And then the 0 of 2 minus 5i gives us the factor of x minus 2 minus 5i. All right, so now it comes the task of multiplying these. Something that you might find helpful would be to leave the complex numbers in their own parentheses, and you'll see why as we go through the multiplication here. So x plus 1 times itself is x squared plus 2x plus 1. And now I'm going to multiply these complex conjugates. The first times the first is x squared. Remember that the outside and the inside of the complex conjugates will always cancel. So now I only need to multiply the last times the last. Well, a negative times a negative is a positive. And now I need to multiply 2 plus 5i times 2 minus 5i. So I'm going to write that down again, just so I don't lose you in any confusion here. All right, so we have x squared plus 2x plus 1, and then x squared plus, well, now we have a pair of conjugates again. And so I'll multiply 2 times 2 is 4. the outside and the inside will cancel, and 5i times negative 5i is negative 25i squared, or plus 25. So we have our trinomial that we've been bringing down, and now x squared plus 29. Take a moment, pause the screencast, and expand or multiply the trinomial times the binomial. Remember to combine like terms. In a moment, turn the screencast back on to check your answer. And so now let me remove the block, and you can see that our polynomial function is degree 4, which it should be. We had 4 zeros. We were given no other instructions, so we don't know if the leading coefficient should be positive or negative, but remember, this is any polynomial function. So if your function did not match mine, you're certainly welcome to pause the screencast and check the work that I did from multiplying here. I'm not going to go through the entire thing, but just so you know, I distributed x squared twice, 2x twice, and 1 twice, and then I added and subtracted like terms.